Okay, here's the second side of the U7A worksheet. All right, let's zoom in here. In 1985, there were 285 cell phone subscribers in small town of Centerville. So we're going to say this is P. This is how much we're starting with. I don't know what kind of formula we have yet, but I know that my P is 285. The number of subscribers increased by 75% per year. That's huge. My goodness. So double time would be 100%. But 75% would be 0.75, and that's what R is. After 1985, that's your starting year. How many cell phones were in Centerville in 1994? So our T is going to be 1994 minus 1885. 1985. So that is what? 9 years? Okay, so we're talking about 9 years. And so 9 years, how many cell phone subscribers were in Centerville? So this is not a compound interest formula. So we're using this formula right here. Y equals A 1 plus R to the T. This is one we're using. It's growing. Growing is plus. So this is the formula we're using. So we have 285 for A, the 1.75, and then we wanted to put in a 9 years. So from 1985 to 1994 is 9 years. So this is a straight calculator here. So go to your blank screen. Clear it out. So we have 285 times 1 plus 0.75, parenthesis, raised to the 9th year. So that means there are, now we're going to round to the nearest person. This is people, so let's round up. So let's go 43,872 subscribers. So they started at 285 back in 1985, and now there's 43,000 people in 1994. So I wonder what it would be now in 2018. I know it doesn't ask that, but from 1985 to 2018, which is this year, it would be 33 years. So if you want to do the same problem with like what it would be now, you can just press second, enter, and it brings back that original formula. And then 9 you can change to 33 years. So this is how many subscribers in cell phone in Centerville now. So this is so big that it's scientific notation. Okay, so you would have to move that decimal 10 places to the right. So it'd be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's a lot. All right, too many to even write. Over 200 billion. If there's that many people in Centerville. It pretty much means everyone that lives in Centerville has a cell phone. Each year, the local country club sponsors a tennis tournament. Play starts with 128 participants. This is P, or A in this case. We'll call it A. During each round, half of the players are eliminated. That means 50% of people are eliminated. Each round, 50%, half. Half means 50% are gone. So R is going to be 0.50 or just 0.5. How many players remain after 5 rounds? So our T is going to be 5 this time, after 5 rounds. So you started with 128. 1 minus, it's going to be minus because you start with 20, and every time you have a round, half of them are gone. So that's 50% are gone. For 5 rounds, how many's left? So it looks like that. It's kind of hard to see that, but I think that's a 4. Looks like 4 people are left after 5 rounds. It's kind of like a tournament, any kind of tournament, like even like the senior tag. You had 128 participants. During each round, half the players are eliminated. So you went from 1. So basically, this is where you started. After round 1, you had 64. Round 2, you're down to 32. Round 3, 16. Round 4, 8. And round 5, 4. The population of Winnemucca, Nevada, can be modeled by this formula. So they're giving us our formula. Where T is the number of years since 1990. What was the population in 1990? So this one, they're asking about the formula. What was the population in 1990? The population was 6191. Let's see, it's modeled with this, where T is the number of years. So this must have been the population in 1990. That was your starting amount. That's the first answer. That's this. By what percent did the population increase each year? That's right here. It's in the problem. So remember how the formula is 1 plus R? This is the R, 0.04. So 4% was the increase each year. So they didn't want you to solve this problem. They just wanted you to know what these numbers meant in the problem. So this was the starting amount of people, and the 4% is the increase each year. So you don't use the 1, because remember the formula is 1 plus R. So 1 plus 0.04 is 1.04. So the 0.04 is the increase each year. So we have inherited land that was purchased. Oh, this is the problem we did in class. Oh, they asked for 2011 though. So it's 30,000. Okay. Land was increased by approximately 5% each year. And from 1960 to 2011 is 51 years. 51? So we're going to put that in. 30,000. 1 plus, oops, I did times. Whoops. 1 plus 0.05 raised to the 51st power. 51 years later, how much is that land worth? Looks like $361,223.09. So land purchased for $30,000, 51 years later would be worth $361,000. So the last one, you deposit $1,600 in an account, find the balance up to 3 years for each of the following situations. So this one's a compounded, and yearly. These formulas, this one, you're going to use this formula. We're using that one for this one and this one. But then this one, because it's yearly, you can still use this formula, but you can also use this formula because it's yearly. Oops. You can just use the simple one, but you can use this one for all of them. All right, so ready? Starting money is $1,600. Put a 1. Interest rate is 2.5%. So let's move our decimal 2 places to the left. So that's going to be the top number of this fraction right here. That's the R. Divided by N. It says compounded monthly. That means N is 12. So there's going to be a 12 here and a 12 there. And it says for 3 years, and that's T. So sometimes I like to go ahead and multiply this 12 times 3 and make that a 36. So it means your money is compounded 36 times in 3 years. So we're going to put this in the calculator. 1,600 is our starting amount. Don't forget that 1 plus. So your interest was 2.5, so it's 0.025. Don't forget the 0. Divided by monthly, which is 12. Parenthesis, raised. And it's monthly for 3 years, so it's 36 times. So put 36. So you should have $1,724.48. So this one, you're going to invest $1,600 again. But this time, it's only going to be a smaller interest rate. This is more like a savings account. So 1 plus, if you move this decimal 2 to the left, it's 0.0175. This one said quarterly. That means N is 4. And then you have another 4 because it's always 4 and 4. That N, see how the N is, oops, I didn't even write the formula right. There's 2 N's in the formula. I'm sorry, I didn't write the formula. There's an N here and an N here. And then number of years is still 3? Still 3. So in 3 years, if it goes quarterly, this exponent is 12. Cross that out. So we're going to go 1,600, parentheses, 1 plus 0.0175 divided by 4, because it's quarterly, raised to quarterly for 3 years, that's 12. So you didn't make as much money this time because the interest rate was lower. So 3 years you didn't make as much money because when you lower the interest rate, you get less money. And the last one pays 4%. So this is the highest interest rate, but it only compounds once a year. This would be a great interest rate if it compounded like monthly, but yearly means it's only going to look at it at the end of the year. But it's still 4% still better than 2.5. So let's see how much better. 1600. 4% is 0.04. Yearly means once a year, but it's still 3 years. So this is 3. Raised to the third for 3 years. So you can tell that you have a little bit more money in this one than you did the first one. 4% is better than 2.5%. 2.5% is better than 1.5. You can see the amounts of money at the end of the year. So always look for a higher interest, and then the more times compounded, the better. And that's it.